Hi everyone, and welcome to another bimco Bites. Today we're continuing our journey with artificial intelligence and looking at Stable Diffusion. We're going to look at a couple of the unique features of Stable Diffusion. We're going to have a look at the interface, and finally we're going to generate some images from some text. So what is Stable Diffusion? Stable Diffusion is a text-to-image model that's primarily used to generate images based on user text input, or otherwise known as prompts. So some of the features that Stable Diffusion has compared to other products on the market, say Midjourney or Dolly, is that it's free and open source. It also runs on the local PC, so not in the cloud, although it can run in the cloud. You have greater freedom because it's on your PC, so you can fine tune, you can set lots of parameters, and you can even code your own training data into it. And also, a lot of the images usually belong to the creator, and the creations remain private. So a lot of the other cloud platforms, the creations that you generate from there are made public by default. And if you want to make them private, you have to pay a higher tier. But by default, they remain private because they're on your computer. However, it's best to seek legal advice if you want to use any of these images for commercial use. Now, if you're looking to get Stable Diffusion installed, we have a lengthy article on our knowledge base. Let me point you to that, as we won't be covering that in this video. Okay, let's have a look at the interface. So I'm actually going to open up Stable Diffusion. It actually appears within my web browser. So by default, Stable Diffusion is a command line interface, which means you don't actually get a graphic user interface like this. So this is kind of like an add-on or a skin that we add on top, but we can use this to interact with Stable Diffusion. Okay, let's start at the top left and make our way down. In the top left over here, you can see we've got what we call Stable Diffusion checkpoints. And if I click on the drop down, you can see that we've got quite a few options here with rather maybe confusing names. So what are these? These are pre-trained models that are used to generate images. And so some models are better at generating certain types of images than others. So for example, some models are better at generating architectural images because they've been trained with additional training data sets. So for example, here you can see, judging by the name, there's one here called Luxury Hotel, another one called Architectural Remix, another architectural one over there. Okay, and I've loaded these in from the web. So I download these checkpoints, all these models from the internet. They're free, open source, and you place them to a particular folder on your computer. Again, I refer you to the installation instructions in our knowledge base. Okay, moving down, we've got our sampling method and steps here. So the sampling method is the algorithm used to produce or denoise the image. It's essentially an algorithm or a way of solving the complex problem that it needs to solve. And generally, we keep this at default setting here. In this case, it's this DPM++ 2M Keras solver here. And sampling steps here over on the right, just to the right of that, they're the number of steps the sampler has to reduce the noise. So the more steps generally, the better the image will be. But by default, we're going to leave that on 20. Here we've got the requested output of width and height of the image. Just a note that if you do decide to change the dimensions of the width or height, it will actually completely change the whole prompt and input into Stable Diffusion. So probably best to set that up first if you're looking for a particular aspect ratio. And then over to the right of that, we've got batch count and size. So the batch count is the number of times that you run the whole image generation pipeline. So say if you had a batch count of 4, it would run the image generation pipeline from start to finish, one at a time, one after the other. But the batch size over here is the number of images that you produce each time you run the image generation pipeline. So generally, image generation using this method, if you increase it, is quicker. But note that this actually uses more VRAM on your computer. Okay. And finally, we're going to have a look at the seed over here. The seed is the random starting point. So we need this to introduce randomness so that every time we hit generate over here in the top right, it'll actually produce another image. If you were to keep the same seed number and hit generate, you'd actually find that you end up with the same image or output every single time. Okay, let's get to the exciting bit. So let's move up here to our prompt area here. You can see here that I've got, just as a starting point, as my prompt, parametric multi-residential building. So if I go and click generate here, keeping in mind that I'm using my Stable Diffusion 1.4 model here, you can see there it's just generated me another image there. I'm gonna hit generate again, just so we get used to it. There's another option there. Pretty interesting. Let's now try increasing the batch size. So say I want, every time I hit generate, I want to produce 2 images. Let's go and try that. So now you can see it's produced me 2 images, and it's also taken a bit longer for it to produce those images. Okay, so you might be noticing at the moment that some of these images aren't very impressive in terms of realism, or they don't seem to, there's always something wrong with them. Like for example, here, it looks like there's a flying starfish of leaves over here. What's going on with that? Well, it's because this particular training data set or model or checkpoint is kind of like a nice general uh, model that covers a lot of topics, kind of like a jack of all trades, but master of none. We want to use a checkpoint or a model that specializes in architectural visualization. And that'll be a lot of like all these other ones that I mentioned earlier that have the words architectural or say hotel in them. So they've been trained specifically with architectural images or photos or renders of architecture. So let's go and create one using one of these models. So say I'm going to swap on over. Well, actually, I might leave it for now. I'm just going to enter my prompt here so just to see what we get. Let's say I want a photo from street level, and I want it to be of a maybe a Melbourne tram in the foreground, a modern, say, curved mixed use skyscraper in the background, and I want you to produce me something at around dawn. Okay, let's just for the sake of time, we'll just make the batch size 1. I'm going to hit generate and see what it gives us. Okay, not too bad. So it's kind of resembling, a tram, and it's got some buildings in the background. Let's try and generate another one. Okay, there's another one. So not bad, but not great. There's kind of a lot of unresolved details here and kind of fusion of a lot of concepts there. So let's change our checkpoint or our model, say to architecture real mix here. And you can see that it's going to load in the file here, the model. All right, let's try running the same prompt again, but now with a new training data set. Let's hit generate and let's see what it gives us. Okay, so that's a lot better, I think. It's kind of got that style that we're probably used to more in the architecture field or photography field, kind of very clean lines and a very particular perspective from street level, and all of our buildings are a little bit more resolved there in terms of edges and horizontal lines. So we're getting somewhere here. I just wanted to show you one that I guess prepared earlier, one I found that I guess was a good one. So I'm going to type in a particular seed that I found, and this is also demonstrating how the seed can be useful. So 152.758.3.1.4.5. 152.758.3.1.4.5. Okay. So now I'm specifying the seed. I'm going to hit generate and see what that gives me. Okay. So you can see that this is a particular image it's generated. And you'll notice that if I hit generate again, because I've specified the seed, it's going to hit generate again. The image doesn't change because our seed has remained the same. So if you wanted to change the seed every time or make it random, you just hit this dice here. And then if you hit generate, it will produce you a completely different image. But if you specify a seed and hit generate, it produces the same one. So why is this useful? Well, if you're going through the ideation phase and you're generating lots of images and you find one that's particularly useful, or one that you like the look of, you can scroll down and find that for this particular image here, that the seed number is here. And you can then reuse that or make note of it. That's something that you like and can come back to it and modify as required. Okay. Let's go and change our seed number to something else, maybe to 8316040997. So obviously I've gone ahead of time and tried to generate some images that I think would be good use cases. Okay, so here's an image of what it's generated. Kind of got the iconic green Melbourne trams there, and a nice looking skyscraper there in the background. But you notice that, for example, in this particular image here, a lot of these overhead lines are looking a bit messy and just visually cluttering up the image. Well, we can actually provide negative prompts up here, and that can try and work those items out of the image. But note that whenever we make a change to any of the parameters, whether it's the prompt or the image size or the sampling steps or even the solver method or the sampling method, it will ultimately change the output. So it's not just going to kind of Photoshop or make these overhead lines disappear. All right, so let's give this a go. So my negative prompt, what I want it to leave out, are overhead lines. So I'm still using the same seed. I'm going to hit generate again. So a similar image, except the tram's completely changed now. We can see that we have much less overhead lines now, and it's even redone the skyscraper for us in the background. So keep in mind that all these images are being run locally. So you can see here on my local local web server here, and these are running off my computer, and I can save these off as required. Okay, let's take a look at another example. My prompt is going to be, I'm just going to delete that from the negative. My prompt is going to be a tropical, luxurious infinity pool overlooking clouds at a large resort in Bali. And I want it to be at dusk and maybe the style of architectural photography. Okay, I'm going to keep everything the same here. I am just going to remove the seed for now. So I'm going to hit the dice to reset that to -1, which essentially makes it random. And let's see what this model produces when I hit generate. Okay, not too bad, but not quite what I was thinking of. Maybe lacking a bit of understanding or connection between the actual resort and the pool here, or might be looking from the other side. Let's go and change this to a different model that has been trained specifically on hotels. So I'm going to change over to the luxury hotel checkpoint here or model. And now let's rerun this and see if we maybe get a better result. Okay, so looking a little bit more dramatic in terms of lighting, you can imagine you're at the end of the pool, looking out, overlooking clouds. So that's starting to look really good. Again, here's one I prepared earlier. So I've got a particular random seed that I want to use to demonstrate 738475. Let's go and run this again. Okay, so you can see they're kind of, got the feeling of being at a resort in Bali. And it's an infinity edge pool. All right, that's looking good. Maybe I want to change dusk to be midday. So again, whenever we change the prompt or change one of these parameter values, it's going to completely change our output, but still get similar concepts. You can see some funny things here, maybe with the cushion of the beds here, the lounge beds, a lot of bit weird, kind of unrationalized edge to the pool there. And you can see the tiles here. I think it's trying to replicate the fact that there's refraction coming through the water. Why don't we try and address that? So I'm going to say in my negative prompt that I don't want to see tiles on the floor of my pool. And let's go and hit generate. Okay, and there's our resulting output of a tropical, luxurious infinity pool overlooking clouds at a large resort in Bali at midday.